Welcome everyone to this speaker session with Pascal Simon. I will call you Pascu during this session because that's how I know you, and it would be strange to call you otherwise. Nice. All right. To everyone who is in this session for the first time, you can answer your questions either by unmuting yourself and ask them directly to Pascal, or there is a chat function on your right top side in which you can ask your questions, and I will transmit them to Pascal. They can also be in German or in French or nothing else. And I will ask them to Pascal directly. Yes, and about Spirit Bird, just a quick information. We have just released this week our roadmap on how it's gonna go further with our application, because we are now building the community for Spirit Bird to make sure that we are having people on the app as soon as we start, and at the same time we are now starting to develop and to implement the application. And in April we will do testings and user research, or we will already start next week with user research, and then the first version or the first flight of Spirit Bird will be on 7th May this year. So very soon. I think it's 6 weeks to go from tomorrow. So we're gonna pour ourselves into this and make Spirit Bird fly, and something everyone in the community wants to use. So now about you, Pascal. Who are you and what brings you here to this speaker session?
Yes, I'm Pascal, and I'm interested in astronomy. I'm interested in very many things in life, but astronomy is one of the things I'm interested since my childhood. And yeah, it started maybe in the kindergarten. I really loved watching the stars, and then I still remember when I first met with my father to observatory, and I still remember that evening, and it was just beautiful. And then I started to read and watch documentaries. Also, I watched lots of science fiction because it's very nice to be out in space. And then I did some training weekends too. And 5 years ago, I started to present at the observatory and the planetarium in Schwanden. That's near where I live, at Lake Thun. And since then, I also started once a year. I do this star night at the Swiss Alpine Hut near Engelberg, and because up there there's fewer light pollution, and it's just awesome to see the Milky Way. And yeah. And if I'm not talking about astronomy, I'm a passionate mountaineer. I work with Mats and Barry Van at Puzzle. 11 years almost now. So yeah,
many things you are doing. Yeah. Very interesting.
Yes.
Nice.
And as in my description, I think astronomy also made me quite open-minded, because the universe is so vast. We're going to see that, and I think that gave me also access to spirituality, and especially I started reading about Buddhism, and then I did karate for 8 years. I was also a karate teacher for 3 years. And then somehow, when I was traveling around the world, I started to do yoga, and that's a leftover from my last journey. And so now I'm going to start a training to become a yoga teacher too. So really look forward to that.
Very nice. What a great leftover from traveling.
Yeah.
And you're going to start this teacher training, I think, with someone we already had a session with, no?
Am I? I think Christina will be a teacher.
And Stephen as well.
And Stephen, of course, yes, Stephen, of course. But,
yes.
Yeah. Yes, of course, yeah.
That's great.
Yeah.
That's great. Yes, I'm very much looking forward to hear what you learned about the universe, and what you learned about this connection between, or for you, what this is something I'm really interested in. What is it for you, this connection between the universe, stars, and the planet, or the galaxy, and spirituality? This is what I'm very much looking for. But you told me that you have a presentation, so
Yeah, I'm
if
going
you would
to try
like to start,
yeah,
just feel free, and
I will.
let's dive into it.
Yeah. So I'm going to start my presentation. So astronomy, mind-blowing science. So when I told Matt, yeah, I would like to talk about astronomy, and he asked me, what does this have to do with spirituality? Sounds nice, but so that's why I'm here now. So I'm going to explain what it has to do with spirituality. And yes, when I started to do these presentations at the planetarium, at the observatory, I really love to see that the people are coming in there. So the planetarium is like a cinema, so we can simulate the night sky and explain it easier than out on the sky. But it's another experience if you're outside, you're more in nature. But for explaining things and showing pictures, it's much better than in the planetarium. And people are coming there, and they don't have any ideas what they are expecting. And then we start to talk about astronomy, and you see people, you see it in the people's eyes that it changes. They start to think, oh, my life is so small compared to that whole thing, and I'm just so small, and it doesn't matter what happens in my life. The universe will just go on with its plan. And yeah, and especially I love it when there's children, especially if they have some knowledge already. That reminds me of myself when I was a child, and you can see that in their eyes are sparkling, and yeah, it's so nice to see that. So most of you would probably say, well, why not talking about astrology? That's more about spirituality. Yeah, astrology is also very nice, but what I really like about astronomy, it's so mind-blowing science. It's a fact. It's science. It's not something that someone has just invented, or maybe someone sees it like this or that. We already know a lot about the universe, and yeah, it's just awesome. What I also really like about astronomy is there is no nationalism, so humankind is just together and doing science there. And I think it's also good to improve peace on Earth, because they all have the same goal, to just understand everything that is happening around us and out there.
One quick question: in the planetarium,
Yes.
is it like a 3D visual thing, or is it
a sphere?
Oh, it's a sphere.
Yeah, and there's a very expensive projector inside, and
yeah,
you have to come and visit.
I really need to come. Yes.
Yeah. I don't know. Did it change the slide? So can you see now the blue slide?
Yes.
Good, great. That's one of my favorite sayings. You're the universe experiencing itself, because it tells everything about our being, and somehow I think life is not happening by accident. Life is really a part of the universe, and the universe is experiencing itself through us, and that's a very nice mindset, I think. But yeah, well, let's go on a journey. That's a picture from one of my high alpine tours last summer. Oliver was also part of it, so he's now also here in these sessions. Nice. And well, out in nature, just untouched nature as far as you can see. I just love it. And you could already see one star. Can someone tell me which star we are seeing here on the picture? Everyone knows it. I see it.
The sun?
Yes, our sun. Yes, true. So our sun is our closest star. So when was the last time you realized that we are living on a sphere out in one could say nowhere, but there's also some small particles around, but you can't really measure them. So when was the last time for you, Max, when you realized, or you thought in the morning you stood up and then, yes, we're on a sphere and it's turning around, and that's what makes night and day. And did you ever think about that?
Yes, I do. Actually, I do very often. And it's funny because, but I think it's because of you that tonight when I saw the sunset from my apartment, I thought, okay, the sun within the last 2 weeks has wandered from one side of what I see to the other side. And then I realized, okay, we're turning. Or is it the sun that is wandering?
Yeah.
That's well. But it was because I know that tonight we're going to talk to you about it.
Nice. Well, actually, we're moving pretty fast, about 1,000 kilometers per hour. So, but it feels also solid around us, but it's not. And it's also a very fragile and small environment. And so many things had to happen that life was possible now as we know it. So it's great. In the back, you can also see the moon. So if you were standing on the moon, what distance do you think is between the Earth and the Moon, and how do we measure distances in the universe or in the solar system? What unit would be best? So
Lichtgeschwindigkeit.
Light speed, yes. Oh, okay. And why are we using light speed? Or light minutes or light years? Because the distances are so big. So if you're standing on the moon, it takes about 1 second for the distance. The light takes 1 second from the Earth to the moon, or vice versa. Yeah. And does anyone know how fast light is?
3,99 Kilometer pro Stunde oder so.
Way more.
That would be quite slow.
4. Nein, warte, 400.
300,000 kilometers per second. So that's 7 times around the Earth. Yeah. So if we're going back to that picture where we standing in the sun, if you're lying in the sun, how far do you think is our sun, our star? So how long does it take from the surface of the sun until it reaches our skin and we feel it or we can see it? How long does light travel about? Any guesses?
10 seconds.
10 seconds? Any more? Less? Yeah, it's about, I resolved the quiz, so it's about 8 minutes already. So imagine this, 8 minutes and 300,000 kilometers per second. And that's a small distance. We're going to see that. So let's visit our sun. This is a picture from a special satellite that is analyzing the sun. And our Earth fits about 1 million times inside our sun. So it's huge. I think our Earth is already huge, but that's even more. And unbelievable, but our sun is a small star. So there are stars that are 1,000 times bigger than our sun. So it's incredible. And well, our sun is 4 billion years old, and it makes a fusion inside, and that creates heat and light, also light. And it's unbelievable, but our sun is losing 4 million tons of mass per second, which is transformed into energy. And that started 4 billion years ago, and she will have another 4 to 6 billion years of fuel to do that. So before it dies, we're going to see that, how stars are born and how stars to die. Well, but let's go to another place first. Where could that be? Any ideas? To give you a hint, at the moment it's about 11 light minutes away.
Then it cannot be Mars, because
that's
Mars.
yeah.
It's Mars. Oh, it's further away than the sun from Earth.
Currently, yes, because it's on the other side of the sun.
All right.
But it's also
currently,
from
okay.
3 to, I think, 14 light minutes from the distance. And Mars is very interesting because Mars is pretty close to our Earth, and it's half of the size of our Earth, and it has a very thin atmosphere. It's not breathable. It's only CO2. And Mars is so interesting because we know that there was water on it, and we believe that there might have been life possible billions of years ago, millions of years. I think it's not billions, and that's why astronomers and also space agencies have so many missions there. Just Perseverance landed maybe a month ago. It's such a complex mission. It's unbelievable. And this mission is searching for traces of recent life. And I think it would be just amazing if we knew that there is also life everywhere on Mars, and that would mean that there's life everywhere in the universe, everywhere in the solar system. This is a photograph of the first rover. I think it landed maybe by the end of the 90s, and now I think it was the 5th rover now, and the rover that is now on the planet is collecting samples, and the ESA, the European Space Agency, is building a spacecraft to collect those samples and bring it back to Earth for analysis.
I have a question to Mars. Sorry, ja, sag nochmal, Freddy.
Aber ich will sie auf Deutsch, ich kann nicht so gut Englisch sprechen. Weißt du, wie sie dann, also auf was sie die Samples prüfen, um zu zeigen, also was sind die Zeichen für Lebewesen dann?
So the question is, what traces are they expecting if there was life on Mars? I think it's different chemical connections that are also only created by organic life. I don't think we're going to find, or maybe there's also dead bacteria or some simple life forms, remains of simple life forms that we can find in those probes.
That is almost the same that I wanted to ask. I hear that often also in the news, like they're trying to find life on Mars, but is it like small organisms they're trying to find, or is it trying to find out if there was life, like human life, that was on Mars once million years ago, or what are they exactly looking for to say there is life on Mars, or there was life on Mars?
Yeah, I think when there was life, was probably pretty simple life, but we're going to be surprised if it's not, if there was even a complexer form of life available there. So would be very interesting. The problem is that Mars lost his magnetic field, and then the atmosphere was destroyed, and that's why it's not so nice to live there. I think the average temperature is about 85 degrees below zero, and the atmosphere is only 100 of our pressure. So yeah, but they have high mountains. The highest, I think, is 16 kilometers high. So. It would be nice for climbing there. Okay, let's go back on Earth and take a look at this beautiful picture. Does anyone know this quite known constellation here with these 3 stars? You can see it in the south at the moment if you go outside.
I think it's Orion.
Yes, Orion. Yeah. So, have you ever thought about what are stars, or what stars are we seeing here? Have you ever thought about how far are they away, or? So we were guessing about distances. So this one, can you see my mouse?
Yes.
Yes, pointer. Yeah. Okay, great. So this star you can see below here, below Uranus is Sirius. That's the most brightest star we can see on Earth. Not to confuse with planets. Venus is a planet, or Mars is brighter because they are illuminated by the sun and just reflecting the light. And Sirius is a star, is a sun, is a double sun. So there's two suns are spinning around the same center, and it's 7 light years away. So most of the stars we are seeing, that's our neighborhood. So for another nice example, that's the Beta Gauss is called this one, and it's a huge star, but it's about 700 light years away. So it means that the light we are receiving, you're seeing, that travels 700 years until it reaches us, and we're still talking about our neighborhood. So it's nothing in cosmic terms. 700 light years. Beta Gauss is also quite an interesting star, because we think that this star is going supernova in the next 3,000, 100,000 years. And maybe that happened already, so the star exploded, but it takes 700 years until the light from the explosion reaches us. We're going to see another supernova later, the Crab Nebula.
I have a small question.
Yes.
In diesem Bild sehen ja die Farben anders aus von den Sternen. Ist das vom Bild, oder ist das wirklich so, dass manchmal ein Stern rötlich oder bläulicher sein kann?
So for those not speaking German, I try to translate. Thank you for the very interesting question. Actually, the question was, are those colors of the stars, are they accurate, or are they just somehow colored to see them? But no, this is really just a photograph, and there is different colors of the stars. It depends on the temperature. So our sun is more reddish, and if you have big stars which burn much hotter, it turns into blue. So it gets more blue. And Beta Gauss, you can see, is a little orange. That's because it's on its end of its life. So it's blowing up, and then it turns red because it's cooling down on the surface. That's the reason. Yes. Okay, so Uranus is a very famous constellation, and you see it on these 3 stars which make the belt from the warrior. So Orion was a warrior in the past, and let's have a look with a telescope in that region. So if you point a telescope on this region, you can see every single dot here is a star. So there's thousands of stars. And also very interesting here, you can also see this fog. That's a region where stars are born. I'm going to explain it later a little bit more. But it's well, that's why I call it mind-blowing science. Our sun is just one of so many stars, and it's just crazy. And I really love that science has gone so far to take those amazing pictures and study all the stars. And we also know that at average, every star is also surrounded by at least one planet. So there's billions of planets. Well, let's go back.
Sorry, this means every dot on this last picture was a sun in our perspective of our sun, like not the same size, but with the same energy.
Yeah, different sizes. So those 3 stars from the belt of the Orion you can see here, they are much bigger and and burn much hotter. So they don't last as long as our sun. Usually,
Wow.
the bigger the star, the shorter its life. So
That's really mind-blowing.
it is. so let's go back to Earth for a moment. This picture was taken by Oliver. He's one of my best friends and a very good photographer. Last year at the Star Night I had in Engelberg in the SAC hut, and there you can see the belt of the Milky Way. So hopefully every one of you have ever seen it, didn't you? So, have you ever thought about what this Milky Way is? Do you know? Or why does it look like a nebula? Dust? No idea.
Because it's like a collection of stars, no?
Yeah.
And there's so many that it looks like dust.
Yeah. So we are inside our galaxy is a spiral galaxy, and we're living inside it, and we are looking inside the disk into the stars, and the problem is we cannot take a picture. I'm going to tell you why. So our Milky Way, that's an artificial. It's a drawing. From the outside, it would look like this. So, any idea how many stars? Well, the Milky Way is our home galaxy. So, any idea how many stars are in that galaxy? Any guesses? Our sun is just one of those stars. So, how many do you think are there if you look at the picture? No idea.
No idea. But is Orion part of this galaxy then?
Yes. The stars we're seeing as just our neighbor stars.
Just
so
us, our galaxy.
We can't see all the stars in the Milky Way.
5 million. Barb means said 5 million.
I mean, much more.
Much more. Wow.
Much more.
10 hoch 15
the mathematics.
Millionen oder so.
How much is that?
Ich weiß es nicht.
So hold on tight. It's about 100 to 400 billion stars in our own galaxy. So that many stars, that needs a lot of space. So if Mats were standing at the left side of the galaxy and I was standing on the right side, and then I had a torch and sending him some SOS signals, how long do you think would it take to reach the other side of our galaxy? So to remember, light makes 300,000 kilometers per second. It takes 8 minutes from our sun to Earth. It takes 7 years from Sirius until it reaches us.
Maybe 40 years.
40?
Yeah.
In 40 years, then you're still in our neighborhood. You're nowhere. It's 125,000 light years.
Almost.
Yes. So and in the middle there is a vast black hole which holds the whole galaxy together, and it takes 20,000 years from our position to the light reaching from the center to us. So we are 25,000 light years away from the center of the Milky Way. And we are enjoying our sun here, and our sun is just one of 100 to 400 billion suns in our Milky Way. Great. Okay. Well, there is probably more than one galaxy. Well, the humankind, people always had different, let's say, opinions about the universe. Once in the past, we were the center of the universe. Then the sun was the center of the universe, and then they repeated again. they revised it again, and then the Milky Way was the whole universe, but they were so wrong. Does anyone know how our neighbor galaxy, what the name of our neighbor galaxy is? Have you ever heard of Andromeda? So Andromeda is our neighbor galaxy, and it's the only object we can see with naked eyes from Earth. And if you point the telescope on it, it looks like this. And Andromeda, hold on tight again, is 1.5 times bigger. So there's 1.5 times more mass than in our Milky Way. So we got a second galaxy inhabiting about 600 billion stars. So how long do you think does the light take to reach us from it? So if you're going to take this photograph, how long did the light travel until it reached our instrument? So to repeat, the Milky Way is 125,000 light years in diameter. So how many distance do you think is between two galaxies?
500,000 light years.
More? 2.2 million light years. So if someone is living there in the Andromeda galaxy and watches our galaxy, it's seeing the light that was sent out 2.2 million years ago. Okay. So we scientists worked hard to improve the telescope even further. So we got this deep field, this famous image from Hubble Space Telescopes. So Hubble is a telescope that is out in space where there's no light pollution and no particles, no atmospheric problems. And what you can see here, most of the dots and lights, those are galaxies. That's not stars. That are galaxies. So should we start to count? So how many galaxies do you think are there on that picture? I don't know it. So it's probably 100. So we know that today we know that there is so many galaxies. They say that's about 1 billion galaxies in the observable universe as we know it. So what we can do, we can't see all of them. Sometimes they're so far away, and we receive light from galaxies that has traveled billions of years. So we can watch we can study galaxies that are exist in a very young universe. That helps us to understand how our galaxy was formed and all these processes. That's a huge fortune for us. But it's just incredible that light could travel for billions of years until it reaches us. So we collected a lot of data and made these models, and also we quite started to understand how stars move, how galaxies move, and then we used supercomputers to calculate how the universe looks today. And that's the picture you can see. So that's the structure of the observable universe as it is now. So all those billions of galaxies are formed in strings, and it looks a little bit like brain. I don't know how neurons, yes, neurons, I think it's the word. Yeah, so unbelievable, isn't it?
Pascal, I have a question with the picture
Yes.
before. There were also some really bright yellow dots. Like are those galaxies in a ending stage, or why are they so bright?
That probably depends on if they are moving towards us or moving away. So if they're moving towards us, they because of the Doppler effect, they turn into red. So the colors has more about the movement of the galaxies and not in the stars, because all the stars accumulated that appears more or less white in white color.
Okay.
Yeah. So that's also a good thing that this Doppler effect. So if a galaxy is moving towards us, it gets red, more reddish. And if it's moving away from us, it turns into blue color. So we can understand how those galaxies are moving.
I have also a question. How do they measure the distance? I mean, I know it's the light and you can measure this in a simple way, but how do they do this in such distances?
Yeah, we have a special documentary at our planetarium which describes this much better than I can do in this short time.
Okay.
But it's you would love it. It's a lot about mathematics, and it's also about Pythagoras. So they started a satellite, the ESA, where there's Switzerland's also part of this European Space Agency. They started this Gaia satellite, and the Gaia satellite is measuring the ankle 2 times a year. So we are on one side of the sun. Then we are measuring the ankle to that other sun. And then half a year later, then we get a triangle, so we can measure that distance. So the Gaia satellite is measuring about 1 billion stars in our galaxy, and all the data is open source. So it's a very interesting project. So that helps us understand how the stars move inside our galaxy.
Thank you.
You're welcome. Thank you for the nice question. Great. So any more questions about galaxies or something that just comes up your mind? Good. Then let's talk about the age of or the history of the universe. So how old do you think is the universe as we know it?
Hard to guess.
Any guesses?
I'm not sure, but it's still early, right? In the process of being a universe.
Yeah, we don't know when it's going to end, so
Okay.
you can just have some guesses, but we're not sure what happens. So 10 years, 20? No, it was before we was there when we were born. So it's about 14 billion years. So I found this nice graphic here. So 13.7 billion years ago, there was this Big Bang. Probably we don't know. It's just the most accepted theory by most scientists. So there was this Big Bang, and ever since the universe is expanding at a fast rate. I think it's currently about 6 kilometers per second. It's expanding. Well, that's also where what I really like about astronomy, that you get really philosophic. So you just can't explain everything. So you have to invent things that it fits all the models, or just have to imagine what it could be, and that's also quite mind blowing, and it's just amazing. So I think our mind cannot understand what's going on here. It's too small. So 13.7 billion years ago, there was this Big Bang, and then about 100,000 years or 300,000 years, it was just dark. There was no stars at all. It was also very hot, and the light was not able to penetrate because it was filled with matter. And then 300,000 years, the first stars start to form. And we're going to see that how stars are forming and how stars do die in the other 2 slides coming up here. But then more and more stars were formed, and every atom you see around you now, or the atoms you are, they were already in a star. So our star is a sun. Our sun is a star of the 2nd generation. That means that there was a huge star before, and then it exploded. And inside our sun, the heaviest element is carbon. So nothing heavier than carbon can be created by the fusion inside our sun. So it needs much more energy to create other very important elements that makes life possible on Earth, or as we know it. So in those supernovas, we're going to see a picture a little bit later. There are heavier elements than carbon created, so it needs a lot of energy. So that's an ongoing process. So new stars are formed, and stars die, and distribute that material again, and then new stars form again. And our sun, but for our sun, that happened about 4 billion years ago. And then the universe started to expand even more, and more galaxies were formed, and that's now we are here on 9 billion years ago. Our planets in our solar system were formed, and now we are 13.7 billion years later after the Big Bang. So many things had to happen that the environment we can see was created, and the environment that makes us possible to live. And nothing is going to last forever in the universe. Even our sun, everything is going to vanish. And our sun will in about 4 billion years, it will have burned all the fuel, and then it will blow up to a red giant and destroy Earth and Mars. And then it will push away its hull, and then will be only a small white dwarf will be left over. Maybe Jupiter and the other stars further away from the sun will survive. And then it's going to cool down and getting dark here. So if you're as far as the scientists know today, in 20 billion or even more years, the universe will expand even more, and it will cool down, and it will just be such a dark and frosty place. Some people think that the whole process is going to turn around again, so it will shrink again. There will be another Big Bang, and then it will start from the beginning.
I have a question, but perhaps it's a stupid question. I don't know.
There are no stupid questions.
Where do the energy go? I mean, it's so warm and hot, and then it ends in a cold and nothing. I cannot imagine what.
Yeah, that's because you cannot destroy energy. That's true, but the universe is expanding even more. So that's why it's down. Just enough space between the energy, so the energy is distributed all around.
Okay.
Yeah, but it's a physical fact. You can't destroy energy. You can just transform it. So let's go to a place where stars are born. This is the Orion Nebula. So if you have the belt up there, there's also the knife on the leg, and that's one of the only nebulas you can see by naked eye. And in this nebulas, there are stars born. So how does this work? So the most common material in the universe is hydrogen. So that's the simplest atom, just one proton in the middle and an electron around it. So gravity makes them come together, and they starting to clump, and there's even more mass, and if there's enough mass, that the pressure inside gets so high that fusion starts to work, and that's how stars are born. So inside this nebula, you can see some very bright young stars here. So that's how our sun formed too. And I just told you that our sun is going to have another 4 billion years, but if the star is much bigger, it doesn't just slowly blow up. It ends in a supernova, and humans were able to see that in the year 2069, I think, and and the leftovers. That's what we call today the Crab Nebula. So the whole debris of that star is now distributed over 4 to 6 light years in diameter here. And you can see that material, so that's also a picture from a telescope. So all that material that's thrown, distributed here, there's going to be new stars forming out of it, and also some heavier elements. So that's why, for example, gold is so valuable, because it needs a lot of energy to build gold, and that's why there's not that much gold than, for example, carbon on our planet. So now the part that Matt wanted to know. I think all the facts and all the pictures, and somehow it I don't know if it's the same for you, but I think I feel so connected to all that. I think I don't separate myself from all that. It's somehow I'm just part of the whole universe, or we are just all part of the universe, and as I told you before, we are the universe experience itself. So we are part of that whole process of birth and death and change, and I think there's real meaning behind our life, and I think life is a real gift, because it takes so much. There was so much happening before that life was possible as it is now. Also on a biological view, so it's so complex with all the cells, and it's just amazing that something like this could happen. And I also believe there's so many different forms of lives in the universe. So the problem is that the distances are so high, but I think there's so many. There's also probably life that is just made out of light, or maybe there's also life in everything around us. Also the sun is kind of life. I don't know. It's so mind-opening for me, and I think that's why I really appreciate life, and think I'm so grateful for everything we have. So, yeah, that's already it's the end of my presentation now, but you're probably interested in even more. So the Rukubelsternnacht is in 1st of September, 2nd September. You have to stay up there, because it's not so nice to walk down in the dark from there. And the other date is the 8th of October. And if you can do it because of the weather, it will be announced on the website a couple of days before. And I would love to see some of you people too up there.
Very nice. Count me in. No, it's really, really mind-blowing, as you said, and for me it's the first time I really hear those facts and figures about the universe. And I didn't know that we know so much. I mean, about distances and about how many galaxies we are guessing there are. And I mean, how big is the chance, if there are already so many suns in our galaxy, how big is the chance that there is so much different forms of life in the universe? And as you say, I am one human on one planet of I don't know how many suns, and also the time sphere. I mean, what you're saying about the time, billions of years, and I'm gonna last for, when I'm lucky, maybe 80, 90 years. and we're
Yeah,
talking
but you're
about
probably
billions of years.
only counting one life. So maybe you're going to reincarnate as a grasshopper, a kind of a grasshopper.
I don't know. But just for what it's what it is for me is also I'd like to do something of this time that it's and as you said, be grateful for having time to spend here. That's really good to know for me, all these things, and I really like to learn more from you. And yes,
I'm happy to tell you everything I know.
Thank you so much.
What I really love about humans, we are so curious, and I think curiosity is such a great thing, and especially in astronomy, you can't be curious enough. So there's so many questions and so many things to study and to find out, and to work together as humankind, not as Swiss or American or what else. Yeah, it's just the same goal for us all, to understand, to be fascinated about the universe and about ourselves, about our being.
And it's very interesting, the picture that you showed, how everything started and where it's going, because if you think about it, that like you said, we are like the consciousness of the universe, like we are experiencing it as the universe, actually, because we are made of the same material as stars, basically. And I think this came to my mind just as I got more into spirituality. I realized more and more that maybe the way we are is just different information, how we are put together, but the energy and the maybe, if you will, the vibrations or something like this are basically the same since the beginning of time, right?
Yeah,
But
I think so too.
just some energies are more passive, if you look at the rock or something like this, and some energies are more active. And yeah, it's really cool that I think you have to get into, maybe not spirituality per se, but just into philosophy, and sooner or later you will end up in spirituality, because there's questions you cannot answer. Like you have to feel into the questions.
Yeah, the most skeptical persons are getting somehow spiritual if you're talking about astronomy, because it's mind blowing, as I told you. And on the other hand, if you go in the other direction and study matter and atoms, the scientists know now that it's literally nothing. So it's a lot of empty space between the atoms, and it's so mind blowing that there's so small particles in such a vast universe.
Mm-hmm.
What's your favorite science fiction movie?
Oh, good question. I'm a big fan of Star Trek, because I like the scientific approach, and also Star Trek, the series, they often talk or have this topic in the series, that what is life, where is life coming from, what kind of life is there, and I really love to philosoph about these topics. But science fiction movies, it's good questions. For example, I like The Fifth Element because it's more funny.
And I love the song. The song
Sorry?
of the and I love the song that the blue lady is singing.
Yeah. It's very funny, and but I think there's also quite a lot. Avatar is pretty nice because it shows other forms of life. I think that's what I like. Interstellar is also pretty good, of course.
Mm-hmm.
And Pascal, there's I don't know if you know this person on YouTube. I think it's called Melody Sheep. I'm gonna post it in the chat as well, so you can watch it later.
Mm-hmm.
He makes like time lapses, kind of into the future and into the past of the Earth, and it's a bit dramatic, to put it that way. It's a little bit a mix of what science, is figured out, and he kind of puts it in a dramatic way, but it's very interesting to watch, and it will be interesting to hear what you have to say about something like this, because I don't know it from like a scientific perspective what it actually means.
Yeah, I'm just a hobby astronomer, so I'm not pretty open.
I just posted it so you can pick it out later.
Yeah. So, any more questions about astronomy, or anything you want to continue to talk?
Maybe how do you connect for you the yoga practice you do? Like how is it influenced by the astronomy, or vice versa?
Yeah, I think the astronomy made me just pretty mind open. So I'm not so sure if there's a direct link for now between yoga and astronomy, but yeah, somehow if when I do those asanas, so I try to imagine that I try to be connected with everything, and if I'm imagine I'm connected with everything, I don't talk about just the surroundings. I talk about the universe, and also if I'm I like to sleep outside in the mountains during summer and watching this beautiful the night sky with the stars, and somehow I feel just very connected to everything, and something very calming, and yeah, just amazing.
Yeah, it's funny because you showed the picture of that looked kind of like a brain. And I feel like sometimes if you do spiritual practice or you meditate, you realize that that this space inside your head is just as vast as the universe in a way. So it has really similarities, from the structure and everything.
And I also think that our being is not really smaller than everything else. So I think size and time doesn't matter. The interesting thing is also that we believe that with the Big Bang, before there was no time and no space, and I cannot imagine how it is without space or time. So that was created during the Big Bang. So we can also philosopher about where in what is the universe expanding in, or how is time created? So many questions.
Yes. It's the same about what you say about the brain structure and about this the atoms of our brain. We know so little about this as well.
Yeah, so complex.
In the universe and in our brain, there's still so much we don't know. We will never know, I think.
Well, maybe our heart knows, but I think our mind cannot understand.
Not in a scientific way.
Mm-hmm. Yeah, in a scientific way. I think we don't need to do that, but anyway, we are curious, so it's nice to talk about.
So we will try as long as we live.
Yeah. I hope I gave you some inputs today that makes your life also, or you can see it from a different angle, and maybe if there's some worries coming up, sometimes just go outside and watch the stars and remember that's so many stars out there.
It's really a new dimension now. When I see the stars, I will go out on the balcony just right now.
Yeah. Also always remember when you see our sun, that's so far away, and it makes life possible as it is on Earth.
And it's one of how many in our galaxy? One of
100 to 400 billion. Übrigens, ich habe ausgerechnet. 400 Billionen sind 4 mal 10 hoch 13. Das heißt, ich war gar nicht so weit entfernt mit 10 hoch 14.
So we got now the scientific proof too. Another scientific. And if you imagine, we already know we discovered about 5,000 planets that are not surrounding our sun. They're surrounding foreign suns, and it's so interesting. Sometimes 1 year on those planets takes a couple of days up to thousands of years, and there's also planets that are so close to the sun that they're always showing the same side. For example, Proxima Centauri is our next star. It's only 4 light years away, and it's surrounded by at least one planet that's pretty close to the star, and it's always showing the same side to the sun. So there's one side always night and one side always day. So we can now think about what kind of life could be created there, or maybe animals that live on the edge between night and day or so, or how does it look like? There's probably a desert on one side, and then yeah, so many things to think about, and also for us a day has 24 hours. That's because the Earth rotates once around every day, and there's all the planets that, for example, Mars. A day on Mars is 24 hours and 50 seconds about, or so, something like that. So it's different on every world. So, for example, Jupiter it takes 12 Earth years to surround the Sun. So one season is 4 years.
That would be terrible. Like 4 years of winter.
Yeah. Yeah, and yes, if people are asking me how old are you, I like to say I'm going to be 21 Mars years that year on 13th of December. So Mars, it takes almost 2 years to surround the Sun.
Okay.
Das erinnert mich mega an den kleinen Prinz. Der war ja auch so auf einem Planet, wo er den Sonnenuntergang verfolgen konnte. Und er konnte irgendwie an einem Tag 40 Sonnenuntergänge sehen oder so. Also, wäre auch cool, auf einem Planeten zu leben.
Yeah. In Star Wars, there's also this planet where there's 2 suns. So we discovered really those planets where there would be 2 suns if you were standing on the surface. Yeah, be awesome. So there's also planets there. It's never night because there's multiple suns around.
Nice. Yeah, thanks for joining. And for everyone, if you want to be informed about future speaker sessions or anything we're doing with Spirit Bird, I just posted the link to, you can join our newsletter or subscribe for the newsletter, or you can join our group chat. We have a Signal chat in which you can share things you think are interesting for the community, and we are sharing also news and all the speaker sessions, and it would be nice to see you there. Thank you very much for joining tonight.
Merci.
Thank you.
Merci, Betty.
Thank you very much. Merci.